Right now, a free piece of software that was just published online this morning is triggering the pouring of thousands of tons of concrete in Austin, Texas.
Yeah, which is just a wild image to think about.
It really is. I mean, usually, we think of software as this invisible code, right? Just floating up in the cloud, completely disconnected from the physical world.
Exactly. But today, the economics of artificial intelligence just slammed into the physical economy with, like, the force of a freight train.
A total freight train. We are tracking a major shift where code isn't just running on computers anymore. It's actually restructuring the global industrial base.
It's a phenomenal collision of digital breakthroughs and, well, physical reality. You really cannot separate the software from the steel anymore.
No, you can't. And to help you make sense of this, we are relying on Aaron Rose's Tech Reader AI Digest, which was published today, Friday, April 24th, 2026.
It's a packed issue today.
Oh, it's huge. And we aren't just walking through 3 isolated tech stories today. We are tracking a very specific causal chain.
Right, a through line.
Yeah. We're going to look at how a sudden, radical cheapening of AI software is triggering this massive, sovereign, physical infrastructure war.
And how that war is bleeding directly into the real economy.
Exactly. Permanently displacing thousands of human workers along the way.
Okay, let's unpack this.
So the first link in that chain is the software Shockwave. DeepSeek just dropped preview versions of V4 Pro and V4 Flash onto Hugging Face.
Just totally open source.
Completely open source under an MIT license.
Wow.
And the timing is deliberate, right? It's exactly 1 year after their R1 model rattled Silicon Valley.
Oh, yeah. Everyone remembers that. But the architecture of V4 Pro is what we really need to scrutinize here.
Absolutely. Let's look at the sheer scale. We're looking at a model with 1.6 trillion total parameters.
Trillion with a T.
Yes, but, and this is key, it only uses 49 billion active parameters per token. And it was pre-trained on an astonishing 33 trillion tokens.
Okay, I want to stop right there and push back on this architecture for a second.
Because if you have a 1.6 trillion parameter model, but it's only waking up 49 billion parameters, to answer my specific question, doesn't it inherently lack the deep multi-step logic of a dense model?
That's a fair question.
Like, how does it keep the big picture reasoning if it's essentially using just a tiny fraction of its brain at any given moment?
Well, that is the defining tension of what we call a mixture of experts, or MOE architecture.
Right.
It doesn't lose the big picture because it relies on a highly advanced router network.
Yeah.
Think of it less like a single brain trying to do everything and more like a massive university.
Okay, I like that. The university.
Yeah. When you ask a complex coding question, the router doesn't wake up the poetry department or the history department.
Right, it doesn't need to.
Exactly. It instantly routes your token to the 49 billion parameters, the experts specializing in Python syntax or logic structuring.
So it gives you that frontier level smarts without requiring a literal nuclear reactor to run a single query.
Exactly. It's wildly efficient.
Which explains the efficiency, yeah. But they also cracked the memory bottleneck.
They did. Aaron Rose notes V4 Pro has a 1 million token context window.
1 million, that's huge.
Right, and it's enabled by what they call a hybrid attention architecture. It combines CSA and HCA.
Now, for anyone who isn't, spending their weekends reading dense machine learning papers.
Which is most people.
Right. The context window usually eats up massive amounts of what's called the KV cache.
Yes.
Basically, the AI's short-term memory of your conversation gets so bloated that it just crashes the system.
It just runs out of RAM.
Exactly. So instead of the AI holding the entire conversation actively in its short-term memory, this hybrid system acts like an ultra-efficient filing cabinet.
That's a great way to put it.
It compresses the data and only pulls the exact folder it needs at that exact millisecond, making it, 90% more efficient than v3.2?
Yep, 90%.
Yeah.
And the way they trained this massive system is equally disruptive.
Oh, the optimizer.
Yeah, they didn't use AtomW, which is the industry standard optimizer.
Right. And an optimizer is essentially the mathematical algorithm that tells the AI how to update its weights and learn from its mistakes during training.
Exactly. DeepSeek trained V4 using a new muon optimizer.
So if the standard AtomW optimizer was like, say, using a compass to navigate a massive 33 trillion token maze,
Sure.
this new muon optimizer is like giving the AI a GPS drone.
I love that analogy.
It's not just moving faster, it's actually seeing the most stable, efficient path to the right answer.
That is a perfect way to visualize it. They fundamentally changed the chemistry of the fuel, and the benchmarks prove that this methodology works.
The benchmarks are terrifying if you're a competitor.
Truly, Look at the SWB verified score. This is a multiple choice test, you know. It measures how well an AI can autonomously solve real-world, complex software engineering issues on GitHub.
And V4 Pro scored, what, 80.6%?
80.6. That virtually ties it with Claude Opus 4.6.
Wow.
And on Codeforces, which measures competitive programming against human developers, it has a rating of 3,206.
Which places it 23rd globally in the world.
Right. It's even hitting a 37.7 on Humanity's last exam.
Insane. And then they dropped V4 Flash, which really brings us to the actual threat to the Western tech giants.
Yeah, the smaller model.
Right, V4 Flash is smaller. 284 billion total parameters, 13 billion active. And it uses only 10% of the single-token inference SVN FLOPs, or computing operations, of their previous V3.2 model.
Which is incredible on its own.
It is. It's like someone dropping a Ferrari engine into the market for the price of a used Honda. But I have to ask you, is this just a pricing stunt to get headlines, or does this actually threaten the big Western AI giants?
Oh, it's a massive threat.
Yeah.
What's fascinating here is, well, the math creates an existential crisis for the current enterprise software model.
Okay, break that down for me.
So DeepSeek V4 Pro costs $3.48 per million output tokens.
Okay.
Claude Opus 4.6 costs $25.
Wait, $25 compared to $3.48?
Exactly.
That's a 7x price gap for near identical coding performance. That
Right.
doesn't just save a company a little bit of money, it fundamentally changes what you can even build.
Entirely.
An automated software testing suite that was literally bankrupting a startup yesterday is suddenly a highly profitable venture today.
Right. Why would any enterprise developer stick with a closed Western API when they can get the exact same performance locally for pennies on the dollar?
They wouldn't.
No, they wouldn't. And that economic reality is driving the geopolitical why of this whole story.
Sovereign parity angle.
Exactly. This isn't just about software pricing. It is about sovereign parity. Because Huawei simultaneously announced that its Ascend 950 supernode will fully support DeepSeek V4 right out of the box.
Out of the box. So the entire stack is localized now.
Completely.
Chinese weights, Chinese inference software, running on Chinese chips.
Yes.
Which is crazy because for years, the core of U.S. tech policy was that export controls on advanced NVIDIA chips would prevent this exact scenario.
We basically assumed they couldn't train or run frontier models without Western hardware.
And that assumption has proven entirely false.
It really has. In fact, you could argue the export controls acted as a forcing function.
Oh, absolutely.
By cutting off access to NVIDIA, the U.S. essentially forced Chinese companies to rapidly iterate and integrate their own domestic hardware and software ecosystems.
And today is the moment that stack achieved frontier performance.
Right. Sovereign parity is no longer some theoretical threat to Western dominance. It is a benchmarked, verifiable reality.
But, and this is the big pivot here, you cannot run a 1.6 trillion parameter model on a laptop.
No, not even close.
The sheer gravity of this software breakthrough instantly creates a massive hardware bottleneck. If the software is suddenly practically free, the value of that's the capital has to flow somewhere else.
It flows into the physical world.
Exactly.
Yeah.
And that is exactly why the tech industry is suddenly pivoting from code to concrete. Which brings us to the terafab build-out.
The physical infrastructure war.
Right. So during Tesla's Q1 earnings call, Elon Musk confirmed that Tesla, SpaceX, and xAI are bypassing TSMC entirely.
Which is a huge deal.
Massive. They are becoming the first major external customers for Intel's next-generation 14A manufacturing process.
Yep.
They're building this sprawling physical complex in Austin, Texas called Terafab, and the market reaction was just violent. Intel stock surged 23.6% today.
Yeah, to understand the magnitude of that stock surge, we really have to look at Intel's recent history.
They're struggling, right?
They were teetering on the edge. The CEO had essentially warned they might have to exit the foundry business entirely.
You mean the actual physical manufacturing of the chips?
Yes. If they couldn't land a massive external client for this specific 14A node, they were in deep trouble.
Wow.
So Musk didn't just place an order, he single-handedly restored their foundry vitality.
Saved them from the brink. And the physical mechanics of this 14A process are just mind-bending to me.
They are.
It relies on high-NA EUV lithography.
Right.
We are talking about machines using extreme ultraviolet lasers, bouncing off the flattest mirrors ever created by human beings to etch microscopic electrical pathways onto silicon.
Sounds like sci-fi.
It really does. And this upgrade brings a 15 to 20% performance boost and a 30% density increase over Intel's previous 18A process.
But the crucial metric for Musk is the power reduction. 14A chips use 25 to 35% less power.
Which is massive when you're buying millions of them.
Exactly. And that matters because of the sheer scale of the terafab goal, which targets 1 terawatt of annual AI compute capacity.
We need to pause on that phrase. 1 terawatt.
It's almost hard to comprehend.
The limiting factor for AI is no longer the chips themselves. It is the electricity required to power them.
Yes. You cannot pull a terawatt of energy off a standard municipal grid.
No, you'd black out the whole state.
Right. You were talking about the energy footprint of small nations here. Achieving that requires dedicated power plants, potentially nuclear small modular reactors, massive cooling systems, and entirely new substations.
Which explains the terrifying capital expenditure numbers we saw. Tesla raised its 2026 capex to over $25 billion just to build this out.
Just for the infrastructure.
Right. They actually beat Q1 revenue estimates, bringing in $22.39 billion. But they still had to warn investors about negative free cash flow for the year.
Because that is how much cash this infrastructure is incinerating right now.
Exactly. But here's where it gets really interesting. NVIDIA also made history today, hitting a record $5.08 trillion market cap.
$5 trillion. Unbelievable.
So I have to ask, if NVIDIA is worth $5 trillion today, and the entire industry relies on TSMC in Taiwan to manufacture those highly coveted chips, why on earth is Musk taking a massive gamble on Intel?
Well, if we connect this to the bigger picture, you realize this isn't just about chip performance.
Okay, what is it about?
It is a long-term survival strategy.
Yeah.
Terafab isn't an isolated project.
Right, Meta has one too.
Exactly. Meta is pouring billions into their Prometheus supercluster.
Yeah.
Anthropic and Amazon are building Project Rainier.
Yeah.
Every single major player is looking at the geopolitical landscape and realizing they are standing on a trapdoor.
Because of Taiwan.
Yes, they are completely dependent on TSMC's factories in Taiwan, and they are entirely beholden to NVIDIA's pricing power.
So they are essentially building sovereign compute infrastructure for the exact same reasons China built sovereign parity.
Yes. The Western tech giants realize they must own the physical dirt, the concrete, the power grid, and the high-NA EUV machines.
Because you cannot commit to a terawatt of compute if a geopolitical crisis in the South China Sea, or even just a sudden price hike from a monopoly vendor, can simply turn off your tap.
Exactly. NVIDIA hitting $5 trillion is the market acknowledging that the picks and shovels of the AI gold rush are incredibly valuable.
Sure.
But Musk partnering with Intel is his way of ensuring he owns his own shovel factory right here in the U.S.
Okay, so we have an escalating arms race of concrete and steel heavily funded by tech giants to support impossibly cheap AI software.
Yes.
But what happens to the layer of human beings currently sitting in the middle of that transition? Because that brings us to the human cost of this infrastructure war. And the numbers in the digest are just staggering. 96,000 tech workers have been laid off in 2026 alone.
And we have to examine the causality behind those numbers, because these aren't traditional layoffs.
No, they're not.
They aren't driven by a recession or a lack of consumer demand.
No, the digest explicitly links the capital allocation here. Meta cut 8,000 jobs specifically to free up the cash for their Prometheus supercluster.
Right.
Microsoft offered buyouts for the first time in its 51-year history. Amazon cut 16,000 people. Block cut 40% of its staff.
It's brutal.
The labor of coding, quality assurance, and middle management is literally being liquidated to buy concrete, steel, and electrical power for AI data centers.
It is a direct transfer of capital from human payrolls to physical compute infrastructure.
Yeah.
And as the models like DeepSeek V4 autonomously handle more of the SWE bench-verified coding tasks,
The need to replenish that human capital simply vanishes.
it just disappears.
Which brings us to Elon Musk's proposal this week on X. He proposed implementing what he calls universal high-GH income, or UHI, distributed via federal government checks.
UHI.
He argues that the productivity surplus generated by AI will eventually eliminate inflation and make human labor, quote, optional, like growing your own vegetables.
That's optional.
Optional, and he puts the probability of this happening at 80%. Now, we need to look at the architecture of this situation objectively.
Yes.
To you listening, we are not taking a political stance on whether this policy is right or wrong, but we have to acknowledge the mechanics here.
It's a bit like the arsonist handing you the blueprints for the new fire station.
Exactly. The very people building the automated systems that are actively liquidating the current workforce are simultaneously drafting the blueprints for the federal government's economic safety net.
It is a remarkable dynamic, and analyzing the mechanics is vital. This raises an important question.
Okay.
What is the actual structural difference between the traditional concept of UBI, Universal Basic Income, and Musk's proposed UHI?
Well, he makes a very deliberate point to separate the two concepts in his framing.
Right, he does, because the underlying economics are completely different.
Right.
Traditional UBI is a model of subsistence. It involves the government redistributing existing tax revenue to create an economic floor, just ensuring people don't starve.
It assumes a finite pie of resources.
Exactly.
Yeah.
But UHI, in his argument, is based on an entirely new paradigm of surplus-driven abundance.
Okay, explain that.
The thesis is that AI systems, combined with robotics, like Tesla's Optimus units replacing physical factory lines, will drop the marginal cost of producing goods and services to near zero.
So things just become incredibly cheap to make.
Right. The sheer volume of cheap production funds. A genuinely high standard of living for everyone, entirely independent of human labor.
But Aaron Rose's digest points out the inherent closed loop in this vision.
It's very close.
When you look closely at the board, Musk is playing every single position.
It is a completely vertically integrated worldview. Just look at the flow of value. He is building the underlying artificial intelligence at XAI. He is building the physical robots at Tesla that will replace the manual labor force.
Yep.
He is building the terafab physical compute infrastructure in Austin to power the intelligence of those robots.
Yeah, now.
And now, he is proposing the federal social policy funded by the unimaginable wealth that his infrastructure generates to manage the millions of displaced workers.
He owns the infrastructure causing the displacement, and he is attempting to architect the societal response.
Precisely.
Rose points out that while some view this as hypocritical, it might actually be the most honest, unfiltered description of the tech industry's ultimate endgame.
I agree.
The goal isn't just to sell software anymore, it's to replace the entire engine of macroeconomic production.
And the displacement we are seeing, those 96,000 jobs, proves this is no longer a theoretical debate for a university think tank somewhere.
No, it's happening right now.
The transition is measurable right now in quarterly earnings reports and severance packages.
It is very real. And the tension surrounding who controls this transition is quite literally going to a courtroom next week.
Yes, the trial.
On Monday, April 27, jury selection begins for the massive Musk versus OpenAI trial.
Massive is an understatement.
We are looking at a 9-member jury, no alternates. Judge Rogers will have the final authority on the $134 billion remedies phase.
$134 billion.
Yeah, which could radically alter the capital structure of the entire industry. So what does this all mean? We started with invisible code getting cheaper and smarter.
And we followed the chain to trillion-dollar physical factories and massive human job losses.
Right. So where does that leave us?
I want to leave you with a concept that wasn't explicitly written in today's digest, but is the inescapable logical endpoint of everything we have discussed.
Okay, let's hear it.
Think about the power dynamics at play here. If a single, highly concentrated cohort of tech leaders builds the impossibly cheap frontier AI software,
Right.
and if those same leaders control the massive physical terawatt energy grids and the sovereign silicon supply chains, and if they are now the ones actively designing and proposing the federal economic safety nets like UHI, what happens to the traditional concept of the nation state?
Wow. When the corporations own the energy, the labor force, and the welfare policy, where does the government actually fit in?
Exactly. We are entirely used to the paradigm of governments regulating technology.
Right. Congress passing laws about social media or whatever.
Yes, but if you look at the physical scale of terafab, the geopolitical reality of DeepSeek's sovereign parity, and the macroeconomic scope of UHI,
It flips the whole script.
we have to ask a much harder question. Are governments regulating tech, or is tech slowly becoming the foundational infrastructure of government itself?
That is a staggering thought to leave on. Thank you so much for taking this deep dive with us today. Remember, the future is no longer just invisible code floating in the cloud.
It definitely isn't.
It is concrete in Austin, it is the global economics of electricity, and it is the policies that will define how we all live. Keep questioning everything.